All right, welcome back and thanks for tuning in again. So this week I want to finish the repair to this Cummins power generation 20 kilowatt GSBB home standby generator set. So this is the one that we looked at last week that had the open in the rotor winding or the field winding, and it was given some intermittent issues. We made a repair to that last week, but it's not complete. We got to finish that and get the thing reassembled and tested. So if you didn't watch last week's video, I will leave a link in the description down below. I would recommend you watch that to give a little bit of context on what I'm doing here. So let's dive right into it. Okay, so here's right where we left off. Now, at the end of last week's video, we completed the repair here to the stator, which consisted of just simply adding a soldered jumper, this is 14 gauge wire, between the pin in the slip ring and the actual stator winding wire, the enameled wire. This was not the failed side. This was actually the failed side right here. So what we need to do is pot this in resin and anchor it securely, because when this rotor is spinning at 3600 RPM, there's going to be a lot of force on this solder joint and this solder joint and on this little thin wire here especially, because you might not think so, but this weight of this solder joint and this piece of wire here actually is pretty considerable when it's spinning around at however many feet per second around a central axis. So what we're going to do is take some of this. This is Stator lacing twine or Stator lacing cord. It's a polyester string essentially, and is what it is what is typically wrapped around stator windings in pretty much any kind of electric motor. Now what we're going to do is put a few turns of this around this this little jumper here and the one on the other side here to anchor it in place, or to at least partially anchor it in place. And then we're going to put some resin around the whole junction here, this whole wire junction, to also hold it firmly in place and resist the forces that were going to be exerted on here when this thing is spinning around. So you're zoomed in on my lacing job, and it might not be the greatest, but I at least have a couple wraps around the 14 gauge copper and one wrap around the enameled wire, the winding wire. This side, similar, got one wrap around the 14 gauge and one wrap along the, can you see that? Yeah, along the enameled wire, just holding it down. Okay, so sorry about the noise, but I have the heater running pointed in this direction here, and I'll go into that in a second. So I've got the stator lacing tape all wrapped around. I got a couple layers over the 14 gauge copper, and I got one layer over the winding wire. Over here you can't really see because I've already started to apply the epoxy, but there's a winding here and a couple windings here just to kind of keep everything seated. So the epoxy I'm using is a urethane that's Loctite 2650. So it comes with this little mixing straw. Sorry about that. So I put a new one on here, and I got the heat here to try to speed up the cure time a little bit, because this is way less viscous than I thought it was. It's quite runny. So I'm just kind of going to work it in around here in these gaps around the wire, flip the armature or the rotor back and forth, kind of work it around and get it to flow in and around where I need it to be. So we'll start over here. Let me get a little bit of this out. Kind of neat how it mixes in there. It sure is nice to be able to put it exactly where you want it. Unfortunately, it's a lot more runny than I thought. while that epoxy is curing on the rotor, let's turn our attention to the stator winding. So remember in the last video, we found these abraded sections of the winding. Let me zoom in on that. Where it looks like something either nibbled away or got wrapped around the rotor shaft and was dragging along here and removed the enamel from these pieces of these wire coils. There, and there's a few others around the outside of the stator. Right there. A couple others. But this is by far the worst area, right in here. But I have a theory about this, and I think it was done at the factory. So what I'm noticing is that this whole stator, the whole assembly here, the frame, the armature, or the lamination and the windings were assembled and dipped in a varnish, because the varnish is on the inside of this housing here, and it was baked. But for whatever reason, they removed the varnish. Here you can see where it's kind of flaking away. It looks like they scraped it away with some kind of tool because the primer paint has been removed. And it looks like they followed it up with like an abrasive wheel, almost like maybe like a sanding disc here, just to clean up the edges. Well, I think that because of these scratches we see in here, I think that the finish, the resin that they used to seal this originally, there must have been some drops or imperfections here that would not allow the rotor to clear. You know, there's a very small gap between the outside of the rotor and the inside of the stator here. So I think they went in here with like a drum sander to try to sand away those high spots, and in doing so they got sloppy going around and around, and they came out and they rammed right into the windings here, based on just how that the paper that lines the slots is abraded there, and the windings. I think that was done at the factory. I don't think a mouse nibbled on that. I don't think anything got wrapped around the rotor. I think that's just shoddy workmanship. So we're going to coat this side of the stator winding with Glipdol. This is a 1201, just basic red enamel insulating varnish. So I'm going to go ahead and do that. Alright, I actually bought a new can of this stuff specifically for this job. So I'm just trying to dab it in on the windings. Kind of use the bristles of the brush to force it in the crevices between the windings. If any of it drips down on the frame, I'm not concerned. It's fairly thick, and well, it's about as thick as like a regular oil-based paint. Tends to stay where you put it, more or less. It helps that I just had the heater running, so everything is all up to temperature here. It's probably about 75 degrees in here right now. Okay, well there's the first coat. Just letting it soak in. So the stator's done. It's got 2 coats of the Glipdol on there. It's not quite dry. It's still a little bit tacky. I think it came out pretty nice. I went and I coated the inner laminations here as well, just to prevent any rust from forming. It's a really thin coating, so it's not going to interfere with the rotor at all. So I've made a little mess here. I should be able to wipe that up with some lacquer thinner. So let's take a look at the rotor. This appears to be curing nicely. Again, like I said, it's still flexible, but it's firm. There's the actual connection. Probably can't. There it is. That little lump right there is the actual solder joint. So I'm going to go ahead and reassemble this thing. I'm not going to show the actual process of that. Not much to see. And then I guess I'll see you when we go to the test run. Okay, so we are hooked up and all ready to test. Got the generator on the right and the load bank on the left. Generator's hooked up to gas. Got a pressure gauge over here. We've got to monitor the gas pressure feeding the generator. There's a little tag right here. Natural gas, 4 to 7 inches of water column. So I don't know if my meter is going to have enough volume to supply this thing at full load, but if the generator starts to lose speed or run poorly, we can always look at the gas pressure gauge and say, hey, well, I don't have enough fuel to run it up to full power or whatever. So that way we know it's a fuel supply fault and not a generator fault. That is if the thing can't carry full load. Got the load bank hooked up here. I like these units. They got a nice big terminal block here to make your connections. Everything's reinstalled and ready to go. So currently, let's see, 40.4 hours on the clock. So I want to run it at least 2 hours at a heavy load to test my repair. Let's see. I think what we'll do, I also have the stroboscope light here. So once we get the thing running under a good load, nice and hot, we'll use the stroboscope and see if we can take a look at the rotor while it's spinning, make sure nothing looks out of place. So I think we're good to go ahead and get started here. I have the front cover here removed just so I can have easier access to it. Once we get it under load and warmed up, I'll put that back on so you can hear. This thing is quite quiet when it's running. Turn the load bank on, fans are going. Let's warm it up. We'll put 3 kilowatts on it. So like I said, this is a 20 kilowatt generator. My load bank is loading both sides, both windings of that generator equally. It's running 240 volts. Now, 20 kilowatt at 240 volts is 83 amps, pretty much 83 amps on the nose. So we know that's our target for full load operation. Let's see, 3 kilowatts, that's where we're at right now. There, I only put 14 amps on it. We'll be nice and let it warm up at 3 kilowatts for a few minutes. Okay, the engine should be fully warmed up at this time, so let's increase the load. So we got 3 kilowatts on it now. Let's go to 6. Let's go to 9. It's 9 kilowatts. Fuel pressure is about 5.5 inches of water column. We're drawing right about 40 amps, 39.7, 39.8, right about 40 amps at 240 volt. And the generator's output is 240 volts, 239, 240 at 60 hertz on the nose. Hopefully you can hear what I'm saying. Bit more. So we're at 9 kilowatts. Let's give it 12. Approach higher and higher loads, I'm going to want to close the clamshell there. That is actually a part of the engine's cooling system, or the unit's cooling system, I should say. So the fresh air is being drawn in through that screen right there, the engine's flywheel, and also at the generator end. That cool air is being pushed over the engine, and the cool air from the rear is obviously going over the generator. They converge in the center and are pushed down past the muffler and then out the back, out of the rim of the lid. So right now, the only thing that's cooling the muffler is natural convection, the heat rising off of the muffler. It seems pretty happy. Let's see what the gas pressure's doing. Dancing around between 4.5 to 5.5 inches of water. So I'm going to say we're just over 50% load here. So I'm going to say my gas meter is a little undersized to run this thing. I've been at 53 amps for about 5 minutes now. I lowered the lid on the enclosure. Seems to be doing quite well. I think it's time to give it all she's got. Remember, we are about 4.5 to 5 inches of water column, so we're at the ragged edge of the gas pressure range. We are at 12 kilowatt. Let's give her 15. Pressure's holding. Ooh, that's interesting. Governor overload. That is interesting. I wonder if it was just pushing wide open throttle at that point when it hit 15 kilowatt. So what I just did there, after it shut down, I opened the breaker feeding the load bank and restarted the generator immediately because I didn't want it to shut down hot. That's interesting. I don't like to shut down my load bank hot either, but that's what happens. Let's put some load back on it. Well, maybe 12 kilowatt is all it can muster on my meager gas supply there. I'm going to bring it back up to 12 and go pull up the manual and see what it says about that governor overload fault. So currently the unit is running at 15 kilowatts. I was able to get it there using the variable control on my load bank. Instead of dumping power on there or dumping load in blocks, like 3 or 6 or 9 kilowatt, my load bank has a 0 to 3 kilowatt rheostat, or variac I should say. So I was able to get it to 15. So set it at 13, it was running just fine, and use the variable variac to bring it up to 15. So here's the manual I pulled up on the Cummins website. So fault 22, governor actuator overload. So we got maximum governor output. It's a pulse width modulated signal for 10 seconds while the fuel pressure switch is open and current is at 100%. Okay, so there's your possible causes. Generator set loads. Certainly if it was overloaded. Wire connections, fuel supply, air fuel mixture, exhaust system, all that stuff. Okay, so you got some diagnostic and repair steps. So we were actually watching the controller when it shut down. So we know it was running about 59 hertz, which is acceptable. So there's a couple steps there, checking AC frequency, checking wire connections, some information there if you have a propane unit. Then of course fuel supply information, and then basic checks for the governor actuator. So it could be a few different things, of course. You know, it seems to be an engine performance issue, which I think that it's my fuel supply, because I'm riding the ragged edge of the 4 to 7 inch fuel supply pressure. I mean, I'm pretty much right at 4 inches, 4.5 inches of water column, so I could tear into the engine, you know, check for vacuum leaks, do some things like that, readjust the valves, but I don't think that'll gain me anything. I really like to have these units run right at their maximum fuel supply inlet. So I don't think we're going to do anything more. We'll just let it run at 15 kilowatt. We'll try to put a little bit more on with my with the variable control. Maybe we'll get it up to 18. But let's head back out to the unit there. So we are drawing 65 amps, which is a little bit over 15,000 watts. The gen set seems to be doing okay. Let's set the stroboscope up and take a look at the repair to the armature. So here's my stroboscope. Let's see if I can get you close enough to see what I see. hope that's coming up on the camera. Looks good. That came out in the video. This is a super nice tool to have for things like this. You know, you're pretty much, you're stopping time, I like to think of it, while the machine is rotating. So you can see any kind of dynamic faults with rotating machinery. It's pretty cool. Well, I'm standing at about 30 feet away from the generator. And just this clip is just to give you an idea of the noise level. It's really not that bad. I mean, if you were in a residential neighborhood, it'd be a little annoying. Now, mind you, it is at 15 kilowatts, so it's at 75% of rated capacity right now. You got the noise of my load bank as well, so it's not all the generator. Well, we're starting to lose daylight. The generator's been running about an hour and a half. The last hour has been at 65 amps. Let's take a look at it. Take a look at the back end here. About to lose all daylight. So here's where we're at. 65.8 amps. Now, if I try to increase the load any further, we trip the governor fault again. But I think the reason for that is I made an error. So, full rated current for this unit on natural gas is only 71 amps. So it's not true 20 kilowatt on natural gas. I should have looked at that in the earlier in the video. It's stamped right there on the nameplate. So we're pretty darn close to full load on natural gas at this point. We're not quite there though, but I have a feeling that if my gas pressure was a little bit higher, we'd be able to put it right there at 71 amps. Let's see how we're doing here. So we're right at 2 hours of runtime, and I'm happy with that. So my limiting factor here is gas pressure. I can't get this thing right to 100% load on natural gas, but we're pretty darn close. What are we at now? .66 amps. So that's not bad. We've been there for about, well, a good hour and a half, I would say. So I'm going to call that good and shut the load off and end this test. So I'm not going to keep this generator. I'm probably going to sell it. It seems to work pretty well. I'm confident. The nice thing is I have an automatic transfer switch to go with it. So it'd be a good package for somebody. I don't think there's any major flaws with the design other than that rotor issue. Runs really smooth. I think this is going to be an end to this video. If you have any questions or suggestions, leave a comment down below.